All right, so I'm gonna do what I can with this 55 minutes, but you know my office hours 12 to 1 today, tomorrow, Wednesday. Be too late on Wednesday, huh? So today, tomorrow, 12 to 1, right down the hall. Be glad to help you. Tutoring Center, Roberto. You go to any of Roberto's hours. He's back there on that wall. You don't have to just go to the 4A. You go to the 4B time, the 103. He'll help you at any of those times. Any of those times. All right, here we go. Cosine inverse of minus root 3 over 2. So how do you do it? With no calculator, huh? Part 1, no calculator. How do you do this? Thing's online, by the way, right? Well, you got it in your hand. What do you care now? Anyway, so you have all the answers too. Yeah, well, it doesn't matter. All right. So remember how inverse function works? This is the answer, and they're asking for the angle, right? It switches inputs and outputs. That's what an inverse function does. Like putting bread, like a de-toaster, an inverse toaster, bread turns it back, toast turns it back into bread kind of thing. Reverses inputs, outputs. So they're basically asking, what angle has a cosine of negative root 3 over 2? Well, remember, for cosine inverse, for the three inverse functions, which quadrants do you look at? You don't look at all four quadrants. Remember, it's only two quadrants?
1 and 2.
Yeah, so for cosine inverse, good job. It's 1 and 2 for cosine inverse. What is it for sine inverse and tangent inverse?
-9.
Yeah, these two. So this is not a sine inverse or tangent. Oh, the next one is. Okay, yeah, I'll get to that in a minute. So sine inverse, tangent inverse is -9. I'll do that in the next problem. So let me not clog it up right now. Yeah, so for cosine inverse, you know the answer is somewhere between 0 and 180, right? Because it's got to be those two quadrants. And it's negative. It's negative. What quadrant is cosine negative? This one. It's got to be somewhere in here, doesn't it? Because remember, all students take calculus. They're all positive in the first quadrant. So it's not, this is a negative answer, so it's got to be second quadrant. Everybody with me? You don't use all four, even though I just wrote all four. You only use for the inverse trig functions. I hope you caught when we went through those sections. It's only two quadrants. For cosine inverse, it's just these two. Number 2 in a minute. Tangent inverse and sine inverse, it's the right two. Anyway, so we know it's this quadrant. We know it's this quadrant right here, which is between 0 and 180. You can eliminate, just from that, you can eliminate a lot of possibilities, right? It's not pi over 3. No way. What's pi over 3? That's 180 over 3. Remember, pi is 180? That's 60 degrees. That'd be in quadrant 1. Can't be pi over 6. That's 30 degrees. No way. It's either A or B or none, right? For sure. Anyway, you don't need to work that way. Let's just go ahead. But if you're really in a dilemma and you just don't remember anymore, at least you remember that much. You're down to two, I guess, 3 options altogether. Anyway, how do we find out? So where is cosine inverse negative root 3 over 2? Well, cosine inverse is remember, cosine is the x coordinate. Sine's the y. Remember that? Remember, there's 3 dots here. 1, 2, 3. Now, it's not the middle one, right? Middle one is the root 2 over 2 stuff. Remember the 3 values, right? A half, root 2 over 2, root 3 over 2. Small, medium, large. Small, medium, large. Root 1, root 2, root 3 over 2. It's not the middle one, because it's not a root 2 over 2. It's one of these two. And you might say, what do you mean it's large? Well, I mean it's one of these 2 dots, is what I mean, right? So which one is it? This one's back a little bit, up a lot. So that one's only back a half, his x coordinate. It's not that. It's the one that's here, back a whole bunch, up a little. It's that one, back root 3 over 2. It's this one, isn't it? Everybody see that? Because that's back a lot. Cosine is x. If that was sine inverse, I would be thinking about how far up it is. Because sine is always how high you are. Cosine is how far over you are, remember? For any dot. So for this dot is back root 3 over 2, up a half, which means his cosine, and then his sine, but I don't really care about sine right now. His cosine is minus root 3 over 2. That's it. So it's this dot right here, which is what? Almost to 180. It's 150 degrees, isn't it? So 150. So convert that. Put the 180 down below. Put the pi up here. So that equals what? 15/18 pi. Is that okay? I just took 150 over 180, 15/18 pi. Good. Divide by, what, 3? Divide by 3, what is that? 5, 6 pi. Hey, there we go. We good on that? You see how I did that? I'm going to move along. So, So I will. I'll stick this up on YouTube as soon as class is over. All right, number 2, tangent inverse. Same kind of thing, but we know tangent inverse is one of these from negative 90 to positive 90, right? Because that's where tan inverse and sine inverse answers always lie. Just those two quadrants, right? Okay, so we're doing tan inverse. Bring it down here. Number 2, tan inverse of root 3 over 3. Now, is it a positive or negative? It's positive. So it's got to be in the first quadrant where everything's positive. It's not the fourth. It's not the other one. Right? All the inverse functions have 2 quadrants. The first one, they all use the first one where they're all positive, and then they use one other quadrant where the negative values are. Right? All right, so anyway, it's positive. So it's up here. So it's either this dot, or this dot. It's one getting kind of scribbly there. So it's one of those 3 dots. How do you know which one? Well, it's a little tricky. You got to figure it out. So I'm just gonna try one out. I'm just gonna say, I don't know. Maybe it's probably not the middle. I'm gonna try this one. Over, up. What's this one? I'm just gonna guess. This is over a lot, up a little. Right? Over a lot, up a little. Y'all with me? It's over a lot, up a little. So is that it? I don't know. So it's over root 3 over 2, up a half. And this one is over a little, up a lot. This one's over a half, up root 3 over 2. Remember, cosine is x, sine is y. Cosine is x, sine is y. Which one is it? I don't know. Tangent is sine over cosine, isn't it? Right? Tangent, sine over cosine. So could it be this one? I don't know. Let's try sine over cosine. Everybody see what I'm doing? I'm just putting sine over cosine for that. I'm just trying out that dot. Sine over cosine. Would that work? Would that become this? I don't, maybe. I don't know. I can't tell. Flip it up. I still can't tell. So a half times 2 over root 3. Right? I just flipped it up like we've always learned. These cancel. You get 1 over root 3. Is that the same as this? Oh, it is. It is. Because if you multiply top and bottom by root 3, right? Remember, you get rid of the root. Top and bottom by root 3. You get root 3 over plane 3. Yeah, that's it. It's this dot right here, which is what? Just 30 degrees. So that's pi over 6, huh? Take 30 degrees. That's pi over 6. You can convert it. Pi over 6. Yeah, see. We good? So I found that. Just tried it out. Tangent, sine over cosine. Good questions? Feel free to ask. I'd be glad to help. I mean, I'm going to be moving quick, but I'm glad to give a quick help.
That's the answer. None of the above, right?
No, pi over 6.
Oh, I'm looking at number 3. I'm sorry.
Yeah, I know it's confusing. I moved it down here. Yeah, sorry. Yeah, don't. Yeah, we'll do 3 in a second. Yeah, good. 30 degrees, pi over 6. Good. All right. So as you know, the real exam will be very, very similar. Same number of questions, same amount of each type, same kind of thing. Just different particular numbers. Okay. Secant of tangent inverse root 3. These are hard. Okay, how do we do it? Start on the inside. These ones where they mix the 2 functions, these are the hard ones where you got to draw the triangles and do Pythagorean and all that kind of stuff. Pretty tough. Okay, let's do it. I'm just going to put it in the first quadrant. Tangent inverse of root 3 over 3. Well, actually, we just did tangent inverse of root 3 over 3. We know it's pi over 6, but if you notice that, you could really do this problem easily. But let's pretend we didn't notice it, or in the real exam, it's probably not going to be the exact same angle. That was just a coincidence, kind of. So let's just do it straight.
Can I have a few minutes for you?
I'm sorry, I'm busy right now, but I can help you after class.
No, it's because I'm part of the DSPS, and
Right.
I have a test, but and it was your class, and
Uh-huh.
you didn't send it to them.
Oh, okay.
Right now.
Gotcha. Yeah, I'm sorry. You're going to have to reschedule with them. I'm sorry.
Oh, okay then.
Yeah, after class. Sorry. All right, so let's move it right to there, like that. Tangent inverse of root 3 over 3. And so we have to put the, it's some kind of angle theta. So remember that this is always an answer, and this is always an angle. Remember how that works? Remember the switcheroo thing, right? So what you put into an inverse tangent function is an answer, and what comes out is an angle, right? On that, we good so far? All right. So that means there's some angle theta. So remember, you make it the reality in the little triangle. So that means what? That means the tangent of that angle theta is root 3 over 3. It's a 3 there. Root 3 over 3. Is that good? The tangent of the angle theta is root 3 over 3. You okay with what I'm doing right now? I'm just taking the inside right now. I'll get to the secant thing later. But I'm just grab out the inside and I just write the fact that the tangent inverse of this is the answer is some angle, right? It reverses inputs and outputs. Okay, which means what? There's some angle theta whose tangent is root 3 over 3. That's what that means. So put that theta in the triangle and make that triangle reflect this truth. Are you understanding that? So in other words, what's tangent? SOHCAHTOA, right? SOHCAHTOA. SOHCAHTOA. Tangent is opposite over adjacent. Opposite over adjacent. So tangent is opposite over adjacent. Root 3 over 3. Right, this is opposite, adjacent, hypotenuse. We good? So I made that triangle. I made a triangle that reflects this truth, that holds that truth, right? The tangent of theta is root 3 over 3. Good so far? Now, use Pythagorean to find this other side, the hypotenuse. Now that we've got that part done, let's find the hypotenuse. You know the Pythagorean. A squared plus b squared is c squared. So 3 squared plus root 3 squared is c squared. Good to there? So 3 squared is 9. Root 3 squared is plane 3. And that's c squared. That's 12 is c squared. And then root it. Root it. C is the root of 12. Or you can simplify that, right? 4 times 3. The root of 4 is 2 root 3. How are we doing? Am I moving too fast? Right? You fall inside this Pythagorean theorem. A squared plus b squared is c squared. 3 squared plus root 3 squared is c squared. 3 squared is 9. Root 3 just tears off the root. That's 12. Root of 12, 4 times 3. Root of 4 is 2 root 3, right? So that's C. It's 2 root 3. Okay, now that we've done all that, you good so far? We're ready to answer the final question. What's that? It's secant of the tan inverse thing. But what is the tan inverse thing? Theta. Did you follow that? Let me say that again. Remember that inside tangent inverse thing, tangent inverse equals is the same as theta. Remember, what comes out is an angle. Inverse trig functions are reversed. Put in an answer, get out an angle. That means you can replace the whole tan inverse thing with theta. It's an angle, right? It's what comes out of the toaster. It's what comes out of an inverse trig function. It's an angle. So I can replace all of this with theta. So it's secant of theta. This theta in that triangle, as I've made that triangle reflect this truth, right? So secant of theta. What's secant of theta? 1 over cosine theta. Right, or upside, you can just say it's upside down of cosine. What's cosine? SOHCAHTOA. SOHCAHTOA. Cosine is adjacent over hypotenuse. So secant will be upside down to that. Instead of adjacent over hypotenuse, like that, it's upside down, hypotenuse over adjacent. Right? Secant's upside down to cosine. Cosine is adjacent over hypotenuse. So I just flip it. It's hypotenuse over adjacent. We good? And then what's hypotenuse? 2 root 3. What's adjacent? 3. There it is. 2 root 3 over 3. Hopefully that answer's there somewhere. Was that a none of the above? After all that work, it's disturbing, isn't it? It's 2 root 3 over 3. It's none of the above. And that, you guys didn't like that question. 59% missed that one. Does that make sense now? So none of the above. 2 root 3 over 3. We good? Questions? All right, practice that. Let's before we go. All right. Was 4 important? Yeah, 4 is another one you didn't like. Let's see. Sine of the tan inverse, same thing. You guys don't like the. I don't blame you. These are some of the hardest ones. They definitely are. 3 and 4 are absolutely 2 of the hardest problems on the test. So let me help you. Same kind of thing. These double mixed ones are super tough. Sine of tan inverse. So see what you're going to need to recognize. When you see the mix of two functions, one's an inverse, one's a regular, that's when you got to draw the triangle. Right away you go, oh, I got to draw the triangle, Do Pythagorean, that whole thing. That's what you got to do. And you start with the inside. So take out the inside, go, okay, tangent inverse of x, right? You always grab the inside. See what I'm doing, guys? I always grab that inside. Tangent inverse of x equals what? Theta. Remember, it equals an angle. Remember, again, what goes into an inverse is an answer. What comes out is an angle. You with me? Then you make a triangle, a right triangle. Just put it in the first quadrant. Don't even worry about quadrants at all. Just stick it in the first quadrant. That reflects that truth. What truth? There's some angle, theta, and what? The regular tangent of theta is x. Everybody see how I switched from inverse tangent to regular tangent there? So everybody see what I'm doing? Right? When you switch, these guys switch. Like toaster, de-toaster, or toaster, inverse toaster. Right? Right? You put in a regular toaster bread, get out toast. Inverse toaster, put in toast, get out bread. Switches them. Right? Inverse tangent, answer, angle. Regular tangent, angle, answer. Right? Okay. So now, tangent, so katoa. Tangent's opposite over adjacent. Here's theta. Opposite, adjacent, hypotenuse. Make this x over 1. This is x. This is 1. Everybody see that? Because you got to have it to be a fraction, huh? So just make it x over 1. X over 1. Opposite over adjacent. Everybody see that? That good? Are we happy? I'm looking for happiness. You kind of look mixed. Is that good? I know I think it's a little painful, Mr. Aaron. I'm not so happy here. You can learn this stuff, though. You can do it. Just got to take some time, huh? All right, so now, good so far? Now we got to do the Pythagorean, find the hypotenuse, all that same stuff, right? So let's do it. So Pythagorean, a squared plus b squared is c squared. 1 squared plus x squared is c squared, right? 1 squared plus x squared. So that's 1 plus x squared, isn't it? Is c squared. Root it. So it's the square root of 1 plus x squared. Can't really. Oh, you can't root that x squared, by the way. Plus signs and minus signs mean you have to just leave it. Notice you can't just go, oh, root of 1 is 1, the root of x squared is x. You can't do it. I can prove it with numbers real quick. Think about 4 plus 9. What is that? That's the root of 13. It's not the root of 4 is 2 and the root of 9 is 3. It's not 5. Not true. Right? Everybody see that? See how when numbers are, this is how there's too many stinking rules in math to remember them all. There just really are. There are just too many. What you do is you test things. This is what I would do. This is what, not just me, this is what every math science person does. This is what the thinking you want. If you want to go forward, higher and higher in math and science, you need to learn to think that way. You look at this and you go, can I root those guys? I don't remember. There's so many stinking rules. Oh, I'll try it with numbers. Does it work for 4 and 9? Oh, no, doesn't work. Can't do it. Everybody see that? You just test it. Test it. Test it. That's the kind of thinking that you want to start developing. That's logic, right? That's discerning truth by testing, right? I said, can I root 2 things added? Let me try it with numbers. Oh no, that's not true. See that I really encourage that'll take you so far. If you can start doing that more and more and more. That's all math is. It's a bunch of little rules about, and you don't have to remember them all. Just test them with numbers. Okay, anyway, so you got to leave it this way. My point is this has to stay. Pluses and minuses kind of like glue things, and they're stuck, and you can't really root them individually. They're just stuck like that. All right. So now, final question. What is it? Sine of, and what's tangent inverse? What's tangent inverse? Theta. Sine of theta. What's theta? So katoa, opposite over hypotenuse. Opposite hypotenuse. So it's opposite x over hypotenuse, square root of 1 plus x squared. Oh, you can't leave the root in the bottom, can you? All right. I wanted to be done with this thing. All right, let me play their little game and get rid of the, what was it, x over the root of 1 plus x squared. Okay, we can't have the root in the bottom, so you know the game. Multiply root of 1 plus x squared over the root of 1 plus x squared, because we can't leave roots in the bottom, right? So then what do we get? That equals, on the top, x times the root of 1 plus x squared. On the bottom, root of 1 plus x squared, root of 1 plus x squared, 2 matching roots just give you a plain 1 plus x squared, doesn't it? We good there? So I hope that answer's there. Oh, it is. It's A. Nice. That's a tough one. Those 2 are 2 of the toughest on the test. Is that okay? Questions I can answer? All good? Last call. I'm going to move on. Got 20 total. All right, number 5. period of that thing. How you do period? Got a little formula for it? 2 pi over b, definitely on your 3x5 card, right? So I hope as we go through even right now, or whatever you do in the practice, that you're deciding what to put on your 3x5 card, making little notes. That's what I'd be doing. I'd hover on the side of my paper, and I'd write, 3x5, or I'd have a little 3x5, and I'd go the period formula and the, whatever. Put one of the number 3 and 4. Those are two of the hardest problems. Put number 4. Put the whole thing in a 3x5. I don't know if you have room for, but that's a great one to put on. Put the whole thing. Put number 4, the whole thing, on your 3x5 card. And you have an example to compare to during the exam. So 2 pi over b. This is a. Oops. This is a here, b here, c here. Right? Remember the ABC thing? So b is 3, huh? So 2 pi over 3. Oh, that was a nice one. Boom. We're done. That's a little better. All right. On to 6 we go. Phase shift. What's the phase shift formula? Yeah, I made it negative c over b. Math Excel. Clicked on the help button. They did it a little different way. But I'll just use this way, negative c over b. So this is a, b, c. So negative c, which is pi over 3, over b, which is negative 2. Right? The b is whatever's next to x. A, b, c. A, b, c. So b, so the two negatives make positive. Pi over 3. This is 2 over 1. Flip it up. 1 over 2 equals pi over 6. Oh, it's positive.
Yeah, C.
Oh, I didn't notice. Oh, that's tricky. To the
right.
Oh yeah. Oh yeah. No, everything's right. I'm just flipping out. Yeah. It's all good. It's positive, so it's to the right. Yeah. We good on that? Yeah, so that's normal. I was thinking something different. Yeah, is that okay on that? Everybody see how? So definitely 3x5 card phase shift formula, right? Negative c over b. 2 negatives made positive. It's 2 over 1 flipped up. 1 over 2, pi over 6. Positive, so that's to the right. No questions? Good? So yeah, you liked those ones better. All right, so we have negative 3 sine 2 pi x plus 2 pi. Okay, so this is the part, I hope you're doing okay on this. We have a few minutes. I did one of these last time, right? Because I was a little concerned when I looked back over the homework. Because with the homework, you had that kind of graph maker thing that you just kind of click, boom, there it is, right? So I was a little concerned when I saw that you might not be well prepared for answering with a multiple choice graph thing. So let me help again like last time. So what do we need? We need the period. So the period of this thing is 2 pi over b. This is again a, b is the 2 pi, c is that 2 pi. So 2 pi over b, 2 pi over 2 pi. So it's 1. Is this the exact same problem we did
No.
in the last time? Okay. So the period's 1. 2 pi over 2 pi. 2 pi over b. All right. The phase shift is negative c over b. This is c. So negative 2 pi over b, which is also 2 pi, which is negative 1. Phase shift is negative 1. Okay, now what does that mean about the graph? The phase shift is where the thing starts, right? So when I go to make the actual graph up here, it's going to start at negative 1, and it'll end the first cycle at whatever the phase shift is, plus the period, right? Because the period is the width of a cycle. So it starts at the phase shift, goes 1 period, that's where it ends the first cycle. So that'd be what? Negative 1 plus 1, 0. Negative 1, which is the phase shift, it starts at negative 1, plus 1, the period. So the end will equal negative 1 plus 1, 0. The end will be 0, the end of the first cycle. So you guys tracking with me so far? That's how we use the phase shift in the period to get a little snapshot of the first cycle of the picture, the graph, right? You start at the phase shift, and then you add the period, because that's 1 cycle, and that'll tell you where the first period ends. So the first period starts at -1, in so at 0. So now where's that? Well, this is, looking at the graph, this is negative pi over 2. Right here, what's negative pi over 2? Well, this is where you got to remember pi is a number. Pi is about 3, right? 3.14. Good enough. Just think 3. So think, okay, so this is like negative 3 over 2, which divide in your calculator if you're not sure. That's negative 1.5. So this is where it's a little tricky. I think you do need to practice this. It's a little different from the homework to the exam. That's why I give practice exams and everything. I don't want you to be fooled. I really, really don't want to fool you. So, right, so everybody see what's happening there? Negative pi over 2 is basically negative 3/2 approximately, right? Because pi is about 3. So that's negative 1.5. What's my point in all that? Well, I'm supposed to start at -1. So that's like not quite all the way there. Maybe like here or something. Good enough. Just good enough to find the right multiple choice answer. You with me? It's somewhere a little before that is where it's going to begin its first cycle. Now, what is it? It's a sine graph. What does sine always do? Start at 0, end at 0. So it's going to start at a height of 0, and it's going to end at a height of 0 at 0. Because remember, it ends at 0, starts at -1, ends at 0. It's going to start at -1, end at 0. So start at -1, which is about there, end at 0, which is certainly that right there. You with me? It's going to do one whole cycle between -1 and 0. That's about -1 right there. Keep doing that. -1 and 0, right? We good? And what's it going to do in between there? The amplitude is -3, so it's going to go down first, isn't it? It's going to hit 0 halfway between those, isn't it? That's what sine does. Maybe about right there. So it's going to go down to -3, up there, up to +3, and down there. Everybody with me on that? That's what it's going to do between -1. I kind of wrote over the top of the -1 now. This is -1 right there. Between -1 and 0. It's going to go down. Right? Because what does sine always do? Sine starts at 0, hits 0 halfway, hits 0 at the end. That's what sine always does. If this was cosine, I would be starting high or low. Low, because it's -3, Cosine starts high, finishes high, or if it's upside down, starts low, finishes low. It's a U-shape, basically, regular or upside down for cosine. But for sine, it starts 0, ends 0, even hits 0 halfway through. Goes high, goes low. All right, so anyway, so there it is. So which one of those look like that? Is it B? Yeah. Oops, there's my pen here. Yeah, it looks like, there's B. Yeah, see right there. Goes down, goes up, back to 0. Yeah, it's B, isn't it? See that little cycle right there? That's it, huh? See how that's in the right spot? See how that's before the pi over 2? Going down first, then up. You might say, now what about, could it be this one? This one, where does he start going down? Here. He's actually on the pi over 2, almost on it. Then he goes down, up, and then he's not even back. Then he hits 0 here, but he's not back to the origin. He's supposed to hit at the origin. See how that one's off? See how it's not D? Right? It's supposed to do that. Start and then come back to the origin at the end of its first cycle. So it is B. Are we okay with that? How we doing? We happy? How many of you missed that one? Yeah, you weren't very happy about that one. That was another problem one. Is that okay now? Does that make sense? So it's all about phase shift start, phase shift plus period end, one cycle. And finding out what -1 means on that graph. I think that's part of the trick, huh? Those pi over 2, that's 3 over 2. That's 3 halves, 1.5. So figuring out where -1 is on that graph. All right. Okay, so minus 1/4 sine of x minus pi over 3. So, I'll write a little bigger here. Minus 1/4 sine of x minus pi over 3. Okay, you know the drill here. So we're going to find the phase shift. This is A. What's B?
1.
B is 1. It's right there, huh? B is 1. C is negative pi over 3. So phase shift is negative C over B. So negative pi over 3 over 1, which is positive pi over 3, right? So it's negative C, and C is itself negative. So double negative positive pi over 3 over B. B is just 1. So the phase shift is pi over 3. That's where it starts, at positive pi over 3. All right, and then the period, 2 pi over b. So 2 pi over b, 2 pi over b. What's b? b is 1. This period's just 2 pi. So where does it end? It ends at the pi over 3 plus 2 pi, right? Where you start plus the period, right? That's where the first cycle ends. You guys with me? You always want to get the beginning and end of the first cycle. So it starts at pi over 3, the phase shift, add the period. So how do you add pi over 3 and 2 pi?
You gotta find the same denominators.
Yeah, common denominator, huh? So put this over 1, multiply top and bottom by 3. So you get pi over 3 plus 6 pi over 3, which is 7 pi over 3, isn't it? This is 1 pi over 3. So it ends at 7 pi over 3. Starts at pi over 3. All right, so let's go up to that graph. Where's pi over 3? Yeah, it's a little tricky, isn't it? Where's pi over 3? Where's it? And what? This is sine graph, which starts at 0, hits 0 halfway through, and ends at 0. Sine graph starts at pi over 3. Where's pi over 3? Well, this is pi over 2. That's half a pi.
It's a little behind that first.
It's a little behind it. Does everybody see that? Because a third of a pi is less than a half of a pi, right? See, I ate a third of the pie or I ate a half of the pie. Half of the pie is more, right? So the third of a pi is a little bit before, I don't know, somewhere like good enough, roughly there. You know, it doesn't have to be exact. You're just trying to figure out which multiple choice answer, right? Somewhere a little bit before the pi over 2. So that makes sense? A third of a pi is a little lower than a half of a pi. But it's not all the way down to a quarter. That'd be a quarter, huh? Quarter is less. A third is between those two. Okay, so there. And then where's it going to, how far is it going to go to the right? Well, pretty far. I mean, add 2 pi. This is pi to here. So this would be 2 pi to there. You're supposed to add that full amount. So it'd be somewhere over here. Way over there is going to be the 7 pi over 3. Right? Yeah, you know what would probably be easier? Yeah, forget about all this. Forget about all this. This was not a good plan. It'd be much easier to say, look, all we have here is we have 2 whole pies, and then what is this? A third of a pie. So you got 2 1/3 pies. That'd be easier. Right? That's where it's going to end, 2 1/3. Right? Because this is 2 pi, and this is 1/3 of a pie, right? 2 1/3. So it's 2 1/3. So it's just a little bit more than 2 pi. So where's that? Like I said, it's about right here. Just a little, it's 2 1/3. Just a little bit more than 2 pi. Right? I found pi. I went double that to 2 pi, and then I went just a little more to the right. Good enough estimate. You with me? Everybody see what I'm doing there? Just a little more than 2 pi. Okay, let's make the sine curve. What is the sine curve? Now this one's going down first. Very little bit, only down a fourth. So here's -1. He only goes down a little bit. I'm scribbling those, -1. Anyway, he only goes down a little bit. Halfway between, he hits, I don't know where halfway is. I can't tell. Maybe about there, whatever. He's going to go down a little bit, up a little bit. Basically like that. Everybody good there? So which one does that? Which one starts a little to the right? So not A. A's got a weird shape. A's not right. Which one?
It has the wrong phase shift, if I'm not mistaken.
Yeah, it looks like it. I'm going to erase some of this so we can see here. Is it B? B, yeah, B looks like he's starting somewhere like that. He's doing that part of it. So they're just showing that part of it, which is all we need. Yeah, that's right. It's showing that part of it. Yeah, that's the right graph. Everybody see that? They're only showing part of it, but it's the right part. They went back more, but everybody see that part matches that part? Everybody see that? Whereas A does not, C and D do not. Is that okay? Everybody see that? So it's B. B's the answer. Okay. Number 9. Okay, so y equals -2 cosine 2 pi x. 2 pi x plus 3 pi. So you know the drill, the ABC thing. A, B is 2 pi, C is a 3 pi. So the phase shift is negative C over B, negative 3 pi over 2 pi, which the pi's cancel, is negative 1.5. Just divide them on your calculator. 3 divided by 2. You have your calculator on this part of the test. 1.5, negative 1.5. And then the period is 2 pi over B. So it's 2 pi over B. What's B? 2 pi. The period's 1. So it ends at negative 1.5 plus 1, right? Which is negative 0.5. So it ends at negative 0.5. That's where the first cycle ends. You guys with me on that? We always start at the phase shift. We start at the phase shift, find the period, and then we add the phase shift plus the period. That's where it ends. So we're gonna make a graph, a cosine graph that starts at negative 1.5. Oh, now they're giving me the pi's on there again. So where's negative 1.5? It's right about here. Because remember, pi is 3. This is negative 3 over 2. This is negative 1.5. About. Right? Remember, pi is 3. About. 3.14. So it's going to start about right here. But it doesn't start at 0. The cosine starts high or low. So I'll handle that part in a minute. But I just want to get the x location. It's going to start there. It's going to end at negative 0.5. Where's that? I don't know. So that's negative 1.5. What's this? This is 3 over 4 negative, which is negative 0.75, isn't it? And we're talking about negative 0.5, so that's somewhere over here maybe. About like there. You with me? About like that. It's not quite all the way to negative 0.75. Right? 50 cents isn't quite as much as 75 cents. 0.5, 0.75, right? Somewhere about there. Good so far. See how I'm locating those? You got to turn those pi's into 3's. About. Right? Okay. Now what are we going to do from here? I'm going to put a cosine graph in that zone. Cosine graph. So it's not a sine. If it was a sine graph, I would be starting at 0, hitting 0 halfway through, and then 0 at the end, right? If it was a sine graph. But it's a cosine graph. Cosine graph makes a U shape. But this is a negative cosine graph. So it's an upside down U, isn't it? So it'll start low. Where will it start? Negative 2. So it'll start at negative 2. About right here. That's negative 2. And it'll end right here. And kind of do a U thing in between. Everybody see that? Up to positive 2. Down to negative 2. It'll do an upside down U. Because it's a cosine graph. It's a negative cosine graph. It's been turned upside down. And it's going between negative 1.5 and negative 0.5.
Does it go inside those dots, like the 1.5 and the negative 0.5? Or should it hit it? You know what I'm talking about? The curve.
What's that?
You see how you put the curve inside those two dots?
What do you mean inside those two dots? Inside. What do you mean by inside?
Start and end. Phase shift and the point.
Yeah, I know the two dots, but what do you mean by I put them inside?
Like the cosine curve.
Uh-huh.
It's like in between, isn't it? Two dots.
So, but if by in between you mean this is the start and this is the end of one cycle?
I just mean the way you drew it. You drew it in between two dots.
On the x-axis, you have the lines going through them. The two lines.
So, at this X location,
Yeah, I was wondering if the curve is supposed to hit that dot or not.
oh, you mean this dot?
Yeah.
Okay, no, because it's not a sign. I see your question. Yeah, does that make sense? So I'm just focused on the X location. As far as where is it height-wise,
Yeah.
the cosine or sine determines that. Yeah, good question. Everybody see that? Yeah, the reason it doesn't start where that arrow is pointing is because it's not a sine. Sine always starts in the midline. Sine always starts in the middle, but cosine never starts in the middle. It starts high or low. Yeah, good question. I'm sure other people have the same question. That's a good question. Does everybody see that? Right? It's a good question. It starts on that dotted line somewhere, but not in the middle because it's not a sine. Right? Sine starts in the midline, starts at 0 height. Hits 0 height in the middle and 0 height at the end. Sine does. But cosine starts high, ends high. If it's a normal cosine, like a U shape. If it's a negative cosine, which this one is, whoops, negative cosine, it starts low, ends low. Not starts in the midline. That's a good question. Everybody see that? So it's going to do that. So now, which one of those graphs does that? I don't know. Boy, it's hard to tell. Let's see. So starts at negative. So it's going to start low at negative. What is it? It's all scribbled all over now. Negative pi over 2 back there, huh? Let me get rid of this. Negative pi over 2. So negative pi over 2, it starts low. This one seems to start low at negative pi over 2. And that looks kind of right, almost.
That's the answer, 8.
Yeah, let's see if some other... Now this one seems to start low, but he doesn't get low again till over here. So it's B, not B. Yeah, it is A. Let's just double check, though. I would double check. So it's not B because his second dot is way off. Second dot's supposed to be right here, huh? Like this one. How about this one? This one is kind of right, but look, it's supposed to be past. See how the second dot is supposed to be to the right of pi over 4? And this one's like right on pi over 4. That one's off a little bit. And the first dot is even a little bit left of pi over 2, if you look. We're supposed to be right of pi over 2. Or basically, well, close to it. Yeah. That one's not quite right. That one's close, though. And this one's not right. At negative, he's too far left of negative pi over 2, and he's too far left of that. Yeah. Yeah, I guess the main thing is the second dot is to the right of the pi over 4. This second dot is right on the pi over 4. That's not correct. Right? See the second dot here is at 0.5, not negative 0.75. The ending is 0.5. And this location, pi over 4, is negative 0.75. Oh, I'm erasing it. All right, enough. I got to move on. Come. So number 11. Okay, so which one is that? Well, first off, it looks like it comes up to 3 and down to minus 3. So it's not a 2 cosine. It's not a 2 cosine. It's one of them. It's one of these guys, isn't it? So which one of those is it? How we figure it out? Well, can you tell what the period on this thing is? Yeah, good job. Remember, cosine's period starts high, ends high. There's one cycle of cosine. How far does that go? From 0 to 4. The period on this thing is clearly 4, isn't it? You see that? Everybody see that? Remember, cosine does his thing. Starts high, ends high. Everybody got that fundamental concept down. Cosine starts high, ends high. Sine starts 0, hits 0 halfway, ends 0. Sine and cosine are just shifted from each other. So the period is clearly 4. So I just grabbed one cycle, one U shape. Period's 4, which means what? Which means 2 pi over b is 4. Would that work for this one? 2 pi over 2 pi. His period would be 2 pi over 2 pi would be 1. That's not right. This one's period would be 2 pi over b. What's b? Pi over 2. Flip that up. That's 2 pi times 2 over pi. Cancel. 4. Yep. C's period is 4. Just like the real graph. Good on that? It's one way. There's a lot of other ways you can do that one too. I'm going to move on. Tangent graphs.
Negative pi.
Yeah, so you want to have you want to put on your 3x5 card the basic tangent, which goes from negative pi over 2 to positive pi over 2 and does the snake thing, and then just keeps repeating that, right? That's the basic tangent. So remember what we learned for those other 4. You have the sine and the cosine, which we spent a lot of time on, and then the other 4 graphs was a different section: tangent, secant, cotangent, cosecant, right? And we learned that both the tangent and the secant go between negative pi over 2 and pi over 2 and do their thing, don't they? And the cosecant, cotangent, remember what they do? They go between 0 and pi and do their thing. Do you have all that in your 3x5 card? Want to have those facts down. So therefore, you take the inside argument right? The x plus, what is that, pi over 2? X plus pi over 2. Well, here, let me do it down here so we have room to graph it there. Take the x plus pi over 2, and you put it between negative pi over 2 and positive. Remember how we learned to do that? Remember for the other 4 trig functions, we graph them completely different style, technique. I gave you a different way, which I thought would be easier for them. Right? Because they all have asymptote lines. You with me? The other 4 trig functions, other than sine or cosine, the other 4, secant, cosecant, tangent, cotangent, they all have asymptote lines, vertical dotted lines, don't they? And let those serve as your barriers, and the graph is in the middle, right? And how do you find the barriers? Well, they're always negative pi over 2 to pi over 2 for the 2 non-cos, meaning tangent and secant, right? And then for the cos, cosecant, cotan, it's 0 to pi. And so you just right away write this inequality. You put whatever's inside the parentheses in between the minus pi over 2 and the positive pi over 2, and then you solve the equation. How do you solve it? Subtract pi over 2, subtract pi over 2. You do it all 3. And that's gone. You get x alone. What is this? Pi over 2 minus pi over 2 is 0. This is minus 1 over pi over 2 minus another minus 2 pi over 2, meaning minus pi. So x between minus pi and 0, therefore, the tangent will do his thing. Between this particular one will do his thing between minus pi and 0. Now that's kind of off the screen. Let me put it over here. So this is minus pi over 2, so minus pi would be about right there. So between minus pi and 0, so dotted at minus pi, dotted at 0. And what will he do? He'll do his tangent thing, which is his snake thing, but this one has a negative in the front. Everybody, maybe I should make it bigger. Everybody see it? It has a negative in the front, so it does upside down snaky thing, right? Like that? Everybody with me? Between negative pi and 0. Does its upside down snaky thing. Then it just keeps repeating. Just keeps repeating, so every pi. Everybody see how that's a width of pi? So there'll be another one here. And it'll do an upside down snake thing. And just keep going. See how I'm doing that every pi? So negative pi to 0 to pi to 2 pi. There'll be dotted, dotted, dotted vertical asymptote line. So, which one of those does that? Is it B?
Yeah, that's only one that reflects.
Yeah, C and D are on the next page, but looks like B. Oh, is that the only one that's upside down at all? Oh, that was easy question. Okay. Cotan, remember what you do. For cotan and cosecant, you put it between 0 and pi. Right? Instead of negative pi over 2 and pi over 2, you put what? The argument in the middle. Pi over 2x, like that. Good. And then solve for x. How do I solve this for x? What do I do? Can I subtract pi over 2? No, that's not added, huh? Yeah, you gotta divide by pi over 2. Or multiply by 2 over pi, whatever, either way. So divide through by, I'll just do divide through by pi over 2. Gets x on. 0 over anything is just 0. This one is pi times, and then flip that thing upside down, 2 over pi, that's pi over 1. These cancel, that's 2. So x is between 0 and 2. So the asymptote lines, the vertical asymptote lines go between 0 and 2, don't they? So 0, right here, and 2. Now where's 2? Well, here's pi, which is 3. Right? Remember, pi is 3. Pi over 2, half of 3 is 1.5. So 2 is somewhere between those guys. About like there, huh? Is that good? 0 and 2. Everybody see that? So you got to deal with those pi's. Remember, pi is 3. And what does cotan do now? He's the snake the other way, right? The tangent does this low to high snake. That's tangent. Cotan, unless he's been flipped or something, goes the other way, doesn't he? Remember, cotan's the other way? So cotan will go the other way. Be right in here like this. This is a normal oh, he's a 3, but that just means he goes up faster and down faster. He's going to do like that. He's going to do like that on that one. So you have to look, we're running out of time. It's not A or B, it's C on the next page. It's all about finding that 0 to 3 boundary there on that one. All right, well, it looks like we're out of time. So we got 13 of them done.